So that we have the question number 5 is of the form solve. We have each of 3 marks question. First sub question we have in it, form the simultaneous linear equation using the determinants. Determinant D we have of order 2 having the entries 4 minus 3 2 5 and dx be the determinant of order 2 having the entries 5 minus 3 9 and 5. Dy be the determinant of order 2 having the entries 4 5 2 and 9. So that we well known, once we are having the linear equation in two variables are of the form a1x plus b1y that is equals to c1. Let's call it as the equation number 1, and the other equation we have a2x plus b2y that is equals to c2, called it as the equation number 2. So to find the value of determinant D, we have it is of order 2. Entries under determinant D, we have the coefficients of variable x and y from equation 1 and 2, that are a1 b1 a2 b2. Now to evaluate the value of determinant dx, it is of again order 2. What shall we have to do? Try to replace the coefficient of variable x from D by the constants c1 and c2, so that we are getting c1 c2 be the first column of dx and b1 b2, that means the coefficient of variable y from both equation remains unchanged from D. Now to evaluate the value dy, what shall we have to do? We have to replace now the coefficients of variable y from D by the constants, that is c1 and c2, while the coefficient of variable x remains unchanged from D, that is a1 and a2. Now once we compare the given determinants d, dx and dy with d, dx and dy by the Cramer's rule, we are getting the values of a1 b1 c1, a2 b2 c2 are of the form. Let's try to compare the D with the standard form of determinant D, a1 b1 a2 b2. We are getting the value of a1 is 4, while value of a2 is we have a2, then value of b1 is we have a minus of 3, and value of b2 is we have a 5. Now let's try to compare dx with the given dx. We have c1 value becomes at that time 5, while c2 value becomes we have the 9, while the b1 b2 remains unchanged from D, that are minus 3 and 5. Same thing here, we have minus 3 and 5. Once we compare the dy, a1 and a2 are the coefficients of variable x from the given equations, so that 4 and 2 remains unchanged from the D, while 5 and 9 becomes the constants, that are the values of c1 and c2 again. So that now we can able to write the required equations, or we might be says the required simultaneous equations in two variable are of the form a1 value. Now we are having a 4, so since from equation 1 and 2 we are getting the simultaneous linear equations in two variable are of the form 4 times x, b1 value we have a minus 3, so plus minus becomes minus of 3 times y, that is equals to we have a c1 which is a 5, and next to it we have a2 value becomes 2, so that we have 2x, then b2 value we have a 5, so that we are getting plus 5y, that is equals to c2 we have a 9. So required equations are of the form 4x minus of 3y equals to 5, and we are having 2x plus 5y that is equals to a 9. Now look at the question number 2. We have, I held a number 75 in my mind. Write any condition showing the relation between their digits. Write the condition showing relation between the number and the number obtained by interchanging the digits. So that we have given the original number is of the form we have 75, where 5 is at 1's place and 7 is at 10's place. And once we interchange the number, so that new number obtained we have, it is of the form now 5 at a 10's and 7 at a 1's. so that we have the 57. Now we have to write any condition that showing the relation between their digits. So look at the digits, we have the 7 and 5. So once we form the numerical equation is of the form 7 plus 5, that is equals to, we have a 12. So let's I am assuming if the tens digit is x and the ones digit is y. So let us have a note, let tens digit is x and ones digit is equals to, we have a y. Then we may form the linear equation in two variable. Try to replace now x by 7 by x and 5 by y. So that should implies now we have the first linear equation in two variable is of the form x plus y, that is equals to, we have a 12. Called it as now the equation number 1. Now once we assumed the two digit number is xy, we interchange the digits, we are getting the new number is of the form yx. Again the same thing, 7 becomes x and 5 becomes, we have a y. So now what happened, once we have the two digit number is xy, once we expand the two digit number, here tens place we have the x, so try to multiply x by 10, and ones place we have the y, so try to multiply y by 1, so that the two digit number whose expansion form we have, it is of the form 10x plus y. And now once we interchange the digits of the original number xy, we are getting a new number as a yx. Y at a tens place, x at a ones place. So once y at a tens place, we have to multiply y by 10, and once x is at a ones place, so that we have to multiply x by 1. So the expanded form of a new number we have, it is of the form 10y plus x. Now we have to write the condition showing the relation between the number and the number obtained by interchanging the digits. So look at the original number, we have 75, and after all interchanging the digits we are getting a number 57. Now once we find the difference between them, we have exactly the 18. That means the original number minus of a new number formed by interchanging the digits of the original number, we are getting 18. That means once we subtract the new number from the original number, we are getting here the subtraction is 18. So that 10x plus y minus of new number 10y plus x, that is equals to, we have 18. Once we open each and every bracket, so that we are getting 10x plus y, plus minus is minus of 10y, plus minus is minus of x, that is equals to 18. So the new linear equation in two variable, we are getting it is of the form 10x minus x becomes 9x, y minus 10y becomes minus of 9y, and that is equals to, we have 18. So here coefficient of variable x, variable y as well as the constant are all divisible by 9. So try to divide throughout equation by 9. We are getting the linear equation in two variable, it is of the form 9x divided by 9, we have the x, minus 9y divided by 9, we have minus of y, that is equals to 9 to 18. That means x minus y is equals to, we have a 2. Called it as the equation number 2. That means the equation first showing the relation between the digits of the original number, while the equation 2 is showing the relation between the original number and the number obtained by the interchanging digits. That means once we have the numerical equations are of the form 7 plus 5 equals to 12 and 75 minus of 57 is equal to 18. Then we have the equations, after all replacing x by 7 by x and 5 by y, we are getting it is of the form x plus y equals to 12 and x minus y equals to a2. Look at the question number 3. Write any two linear equations in two variable in which the value of one variable is 12 and the other is 10. So let us, we are assuming that first variable we have the x whose value is 12 and the second variable we have the y whose value is 10. Now let us try to form the numerical equations by using the numbers 12 and 10. So now once we are having 12 plus 10 that is equals to 22. Try to replace now 12 by its value as a x in terms of variable and a 10 by its value in terms of variable as a y. So that we are getting x plus y that is equals to 12 be the linear equation in two variable. Now next to it, let us try to form the other numerical equation. So that we are having 12 plus 2 times 10 that is equals to 10 2s are 20, 20 plus 12 we are getting 32. So that the other linear equation in two variable, once we replace from the given numerical equation 12 by x and 10 by y, we are getting x plus 2y that is equals to 32. We may use the other numerical equations also, or we may form the other numerical equations also by using 12 and 10. Likewise, supposed to be we are having the other numerical equation is of the form 12 minus 10 that is equals to, we have it to try to replace now 12 by x and 10 by y, so that we are getting linear equation in two variable is of the form x minus y that is equals to a 2. Or we may have the other numerical equation is of the form 2 times 12 minus of 3 times 10. We are taking 3 times 10, let it be. So 12 twos are we have a 24 minus of 3 tens are we have a 30. So the subtraction of them we have a minus of 6. Try to replace now 12 by x, 10 by y. We are getting linear equation in two variable. Here variables we are using x and y. So that we have 2 times x minus of 3 times y that is equal to, we have a minus of 6. So the number of equations we may form by using the numerical equations, such that in the numerical equation strictly we have to use the 12 and 10 be the numbers. Now once we are choosing any two linear equations in two variable among them, so that I am choosing, let us x plus y that is equals to, we have a 22 be the equation number 1, and the other equation, simple equation I am taking x minus y that is equals to 2, let us call it as equation number 2. That means now we have the simultaneous linear equations in two variable, x plus y equals to 22, x minus y equals to 2. Once we are simplifying equation 1 and 2 simultaneously, definitely we are getting the value of x is 12 and the value of y is 10. So let us try to have a number 12 and 10 and form the numerical equation first, and from that numerical equation you have to replace 12 by x and 10 by y, so that you are getting the corresponding linear equation in two variable. And let us write any two linear equations in two variable here. Look at now the question number 4 we have. From the railway station I took a rickshaw to go to home. It is decided that I have to pay rupees x for the first kilometer and for each kilometer rupees y for the next. For 10 kilometers the fare is rupees 40 and for 16 kilometers fare is 58 rupees. Find the fare for the first kilometer. So that we are given here that rupees x be the fare for the first kilometer, and for next upcoming each kilometer I have to pay rupees y. Now look at here, once we have for a first kilometer that is x rupees we have to pay, and we are traveling now 10 kilometers. So among 10, for first kilometer we have to pay x rupees, and for remaining 9 kilometers for each kilometer we have to pay rupees y. Now for 9 that means we have to pay total 9y rupees. So that means total fare we have for first kilometer that is x, and for next 9 kilometers we have to pay for 9y, and the total fare we have given already 40. So that we are getting the first equation of the kind x plus 9y that is equals to a 40. Now look at after we have for 16 kilometers fare is rupees 58 So among 16 kilometer, for first kilometer we have to pay again the X rupees, and for remaining 15 kilometer, for each kilometer we have to pay Y rupees. That means for 15 kilometers ultimately we have to pay in total 15 Y, that much rupees. So that now as per the given, for first kilometer we have to pay the X rupees, and for next 15 kilometers we have to pay 15 Y rupees. So total fare we have, that is 58 already we have given and called it as now the equation number 2. Try to solve that equation 1 and 2 simultaneously, so that fare for first kilometer we are getting the value of X, and fare for next each kilometer, that is we are getting the value of Y. So look at after equation 1 and 2, both are having the same coefficients of variable X, that is 1 and 1. Both are having the same sign, plus and plus, so that we have to subtract equation 1 from 2. That means I am writing equation 2 minus of equation 1. X minus X is 0 or getting cancelled. 15 minus 9 we are getting a 6Y, that is equals to 58 minus 40 we have a 18. Once we shift the 6 from LHS to RHS, so that value of Y becomes 18 divided by 6, that is 3. So that we have to pay rupees 3 for each kilometer after the first kilometer. Now we have to evaluate the value of X here, because here look at after the fare for the first kilometer we have to evaluate. That means let us try to put now the value of Y is 3 in any one of the equation 1 or 2. I am choosing the equation 1. From equation 1 is of the form X plus we have the 9Y, that is equals to a 40. Value of Y we are having here a3. So X plus 9 into 3 we have a 40. 9 3s are we have a 27. So X plus 27, that is equals to we have a 40. Once we shift the 27 from LHS to RHS, so the value of X we are getting here 40 minus of 27, that is 30. So for first kilometer fare is rupees 30. So you may have your answer like way, fare for first kilometer I have 13 rupees. So hence here we have question number 5 from first chapter, linear equation in two variable. Thank you.